What are listed? Majority they are the mechanical SHM, simple harmonic motion. So there are some electrical simple harmonic motions are there. For example, a electrical oscillation. Whenever you take the LC circuit, inductance and capacitance, whenever we supply the energy to that one, current is passed. At that time, the electrical charges, it starts oscillating such that it's move forth and back from inductor to capacitor and capacitor to inductor. So continuously this electrical charge fluctuating between inductor and capacitor. So this is the example for the electrical oscillation. So with this, the basic concept, the mathematical concept we would like to touch upon, that is the differential equation of motion for simple harmonic motion. Whenever the body is executing simple harmonic motion, it can be represented by a sine wave. This is the displacement on either side, and this with respect to the time. That is, when a body is set into oscillation, when it is set into oscillation, the restoring force F, the moment it starts oscillating, the restoring force F, it comes into existence. So that restoring force is given by F is equal to minus K into X. We call it as equation number 1, where X is the displacement and K is the force constant. Now M is the mass which is vibrating. Then from Newton's second law, we know that F is equal to M into A. That is, F is equal to M into A. In differential form, we can write it as d square x by dt square. You call this as equation number 2. Now comparing equation 1 and 2, this equation F is equal to minus kx and F is equal to M into d square x by dt square. Comparing these two, we get M into d square x by dt square is equal to minus kx. Rearranging the term, we get d square x by dt square is equal to minus k by m into x, or d square x by dt square plus k by m into x is equal to 0. You call this as equation number 3. So this equation number 3 represents the equation of motion for body executing a free oscillation or maybe a SHM. This is a differential equation, and when we solve this differential equation, the general solution is given by x is equal to a sine omega t, a sine wave. Previously we have discussed. The last one is, what is the natural frequency of vibration? Whenever it is having SHM, what is the natural frequency associated? Okay, we know that x is equal to a sine omega t. It is the general solution. Whenever we differentiate, it becomes dx by dt is equal to a omega into cos omega t. Differentiating once again, we get is equal to cos omega becomes minus sine, therefore minus a omega square it becomes into sine omega t, or is equal to minus omega square into x, because a sine omega t is given by x, therefore it becomes minus omega square into x. Therefore, rearranging the term, d square x by dt square plus omega square into x is equal to 0. This is equation number 5. So now comparing this equation 5 with equation number 3. So comparing equation 3 and equation number 5, we observe that this omega square is equal to k by m. Therefore, omega is equal to square root of k by m, where this omega is known as the natural frequency of vibration.